Hi, my name is Mike Jesper. Before I start, I'll give a little introduction about myself. Before I joined the Stack team, I was a web developer in the Communication Services portfolio. I was a front-end developer on LDS.org, and most recently was a team dev lead for the church history team in that portfolio. Before working for the church, I worked for Weber State University as a web developer and a startup before then. So just to start off, this is a Donuts.js presentation about unit tests. This is a re-recording because my audio did not record during the real presentation. Facepalm to myself. So today's presentation is about unit tests. So just to start off, I feel like there's two words that I have thought about and pondered in my time here as a web developer and a team lead, and those two words are rigor and professionalism. Rigor is the process of being thorough, accurate, or exhaustive. There are many things when it comes to software engineering that we apply rigor to. Rigor is typically, you find that used in academic or scientific circles, describing a really strict scientific process or a strict academic process that we can work within. Professionalism is another word I've been thinking about recently, and we normally think about professionalism meaning they dress well, they speak in appropriate ways, they treat others appropriately. And that's true. I'd like to break down professionalism in a different way, put the hyphen in a different spot, and pronounce it professionalism, meaning that you do the right thing according to the best practices of your profession, not doing the right thing just in your own self-interest or in the self-interest of your company, your employer. So to put that into application, for example, a doctor is a professional, meaning that they're loyal to the profession of medical practice before they're loyal to their own self-interests. They're going to put the best practices of that community ahead of the needs, the business needs or something like that. And that ties strongly into ethics and doing the right thing according to the best practices of what your profession is. So this talk's going to be a lot about rigor, which is, again, it's being exhaustive, thorough, and accurate. And I feel like in software engineering there are three principles of rigor. There may be more, but these are the three that come to mind to me. One is pair programming. Next is code reviews, followed by unit tests, which is what this talks about. Pair programming, being collaborative, having another set of eyes of your code. Code reviews can be loose or formal depending on your implementation, but just making sure that code is reviewed by other developers before it's merged into your main branch or before it goes out to your deployment. And then unit tests, which I'll obviously elaborate on more. So why do we write unit tests? Let's go to Google and find out. We're going to be talking about the second result, not the third result. So some reasons that we would want to include unit tests. I've found in my experience that projects that include unit tests are safer to build and to deploy, meaning that because you're testing the functionality of a project, when you go ahead and deploy that, you can know that all of those things that you've written in the past are no longer, you don't have to worry about them breaking because there's going to be tests running every time. You can run your unit tests at build time or at deploy time. Your project's going to be easier to refactor. Because you have these unit tests, you can go in and make changes to code and then run tests again to verify that your changes did not change the behavior or the API of those functions. Projects are faster to learn for new developers. They can come in and look through unit tests and easily see what's supposed to go into a project, what's supposed to go out of a project. I don't know how many times this has happened to me. You open a new project on a new team, and you see a huge file, or a huge function, and the input is not named very well, and it may just be an array or a list of things, so you don't even have any idea what's supposed to go into that function. Then it transforms it in some way and returns it as an output. And that function's just, might as well be a black box. It's totally incomprehensible. And so by providing unit tests, a new developer can see what have all the previous developers expected to be going into this function as input, and what do they expect to be returned from this function as output. Unit tests also provide a self-documenting API, meaning that you can read through unit tests and understand the API of all the functions that you're exposing, their methods, signatures, and parameters that they would accept, and the types of objects or data that they would return. So just to be pragmatic, I know that unit tests are not a catch-all be-all, and unit tests could also provide you with a deceptive sense of safety or security. It's important to unit test the right things. It's tempting when you're first starting to write unit tests to write easy tests, test the easy functionality. And that's probably going to be around the periphery of your project, not the core business function and the core business logic of your project. Well, if you don't test the core functionality of your project, then you haven't really given yourself a safety net. You're just testing the stuff around the edges. So it's good to have a sense of safety, but not a deceptive sense of safety. So you need to understand that your unit tests are only going to be testing things that you choose to write tests for. Just including unit tests in general is not going to be a catch-all, end-all for the safety and security of your project. It's important to note that, I think. So a couple definitions. What is a unit? A unit is a function that serves a single purpose, and it maps one input or one set of inputs to one output. These are usually simple to understand and clear functions. What is a test? A test is a function where we can call that function with mock data and observe its output. Every form of testing, school testing, security testing, we're providing input against a system or a person, and then observing the output of that system and measuring that against a known criteria. In school, you're taking a known criteria, which is the answers, and you're providing input to a student and seeing if their output matches the known answers. We're doing the same thing with unit tests. We're taking a known input and output and measuring that against the output of the function we're testing to test its success against what we expect the output to be. So as we're writing units, functions can become smaller, more reusable, and single purpose. And you may recognize these principles as functional. When we write functions that need to be unit tested, those functions become functional. When we write unit tests, we often have to refactor our code to be functional. And so there's almost a cyclical relationship between writing unit tests and writing functional code, that they reinforce each other, which is a positive in my opinion. So there are two different types. Well, there are a lot of different types of code, but three here in this diagram. True tests on the left, which are single small components that have known input and known output. On the right are integration tests, which may be tests of large systems or how multiple components behave together. In the middle, we have this diagram shows dirty hybrids, meaning that it's code that you might want to be a unit. It should serve a single purpose, but it's integrating lots of other parts of a system into it, and so it's really hard to separate those out. So some examples of pure functions, really simple. Add takes two numbers, returns the sum of those two numbers. An integration test would be, or an integration function would be something like a page load function, where you would initialize a bunch of functions or a bunch of modules against your page. And this is now you're dealing with the state of your current page. You're changing some global state in terms of you might be manipulating the DOM or changing all these different things. So these are integrations, seeing how multiple components come together. In the middle, there's this dirty zone where a lot of our code might live, honestly. And it's my belief, or what I want to convince you of today, is that this dirty zone can be cut in half and pushed one way or the other. You can refactor code to turn them into pure functions and push them to that side. And you can refactor your code to turn it into more of an integration or configuration type pattern. and push it out of that dirty zone to enable us to do good tests on both ends. There's a book called The Art of Unit Testing, and it's considered probably the best book on this subject. It's the Bible of unit testing, basically. And it suggests several properties that unit tests should have. They should be automated and repeatable, meaning they're just some code that you can run over and over to test. They should be easy to implement. We have libraries that help us to implement those. Once it's written, it should remain for future use, meaning it's something that's saved with your project. You should check your unit tests in. Anyone should be able to run it, meaning when someone checks your code out, they can run those unit tests after they've installed dependencies. It should run at the push of the button and quickly. I'm going to show you how unit tests can be put into like a JavaScript task runner. I'm going to show using unit tests in Gulp, but they can also be as an NPM script in the package.json. But we like to borrow a lot of terms from math, and we like to borrow a lot of terms from engineering. So when we're talking about functions, if we think about functions from a mathematical point of view, this can give us some insight into writing good functions that can be tested. In math, when functions are unknown, they can be understood and approximated by modeling their values. You can put in values and then take out values. So just as an example, if you are given this function f of x equals y, and given input of this input and this expected outputs, you could take a guess at what the output of that function might be. And your guess is probably going to be wrong because you don't have very much input. So if you get more input, you can make a better guess. And this is similar to, and we can apply this to the concept of testing. As an aside, this is really what test-driven development is. You're given requirements, which are the input and the expected output. And then from those requirements, you're going to iterate on code. You're going to create functions that satisfy those requirements. And that code is going to change as you gain more requirements and write more tests. So just the basic process of writing tests. If you took this is an example function. I'm calling it getUserSettings. It accepts a string. And what it does is it changes that string into an object and then returns an object with either the values of that string or the values of that object from the cookie or default values. So the first thing we're going to do is understand that function and then describe it using natural language. So we're describing the getUserSettings function. It should return an object with data that matches the settings, or it should return the defaults if they don't have settings. We can then take that description and it maps almost one-to-one to an actual test. So this shows code that a test could write to describe the test could be to describe that function. So we're describing the getUserSettings. It should return the default data if nothing's passed in, and then we can assert that properties are false or are equal to each other. Or it should return correct settings if it is passed in a string. It should also return equal or true if those properties exist. So in this example, I'm using Karma and Mocha, and there are lots of different types of testing technologies. These are two that I've chosen to use. Karma is a framework which runs your test. It's like an environment you can run your test in if you want to choose to use Chrome or PhantomJS, if you want to use plugins like Browserify, Webpack, Babel. Mocha is a library which allows you to write the test itself. That's where you're writing, describe and assert dot is true or is false, and it allows you to test those properties against each other. And those tests are going to be run in Karma in this case. So all the training that I've seen on unit tests up until this point in time has been basically the theory that I've already covered. It's been kind of mathematical functions where you're expecting input and returning output, and they're already these discrete units. But those sort of trainings on unit testing haven't helped me because a lot of the code that I'm writing is complex behavior and frankly, a lot of it's DOM manipulation, which is hard to model in a unit testable way. So for example, this is a component that's an image gallery. If you click on an image, one of the small images, it's going to load this big image drawer. So a click loads this flyout. The large image should be from a data attribute on the small one. The image should be responsive because it's a big grid of images and the flyout is absolutely positioned. So we need to do some math to determine its width and its height per the width of the image which is loaded in. The caption should come from a data attribute. Left and right arrows need to navigate back and forth, and the X should close that little flyout or drawer window. So each of these, this whole system is not something I would consider a unit. This is far too complex to be a unit. This is a composition of units, and so you could test this with an integration. But all these individual pieces are little units that we can test. And that all comes down, like I mentioned, all that functionality and complexity boils down to its DOM manipulation. And so I have an example that I'm going to go through that shows how we can write DOM code in a way that it can be unit tested, and then show how we can write the unit test itself. Alright, so on the top, make my fonts nice and big here. In the top window, I have a very simple function called gallery, and it looks at the document and finds the close button, adds an event listener to it. When that click event happens, it finds the flyout and deletes it from the DOM. And below I have another file, which is the test file. So in the test file, we're importing the test framework, chai. We're importing the image gallery function, and then starting our test. So the first thing it says is we're describing the photo gallery. Everything within this scope of this test is going to describe the gallery. Then we can break that down into small bits. So let's make sure it's defined correctly. We're just going to assert that it's a function. Next thing we're going to do is we're going to describe the close button. You notice the gallery doesn't do anything else except close the flyout, because this is an example, and it's an isolated example to show you the principles of unit testing and of refactoring. And so this describes the close button, and the assertion is it should remove the drawer when it's clicked. So we can go ahead and run this test as it is now, and let's observe what happens. Alright, so it worked, although we're not actually testing anything. And so it worked, but this is our false sense of security. And so now we're going to write some code that will change it so we're testing the actual behavior, not just an empty test. So let's look at this gallery first of all. And as you observe and look at the code for the gallery, there are a couple things that you can notice that are going to make it so it's hard to be unit testable. One thing that stands out to me is that we rely on the document. We rely on the fact that the document has these properties like query selector. These are DOM API functions that are not native to JavaScript. And the fact that this document even exists in the context that it's being run. We're running this in this, Phantom.js, which is a headless browser. We might be running it in a little Chrome instance. And so when this is running, this may not exist in the first place. And the document, again, is kind of a global state. The DOM is the ultimate global state in a web page. And so the first thing we can do to refactor this function is, instead of using document, we can pass in a DOM fragment or a context. So I'm going to use ES6 syntax to pass in a default parameter. By default, it's going to be an empty function. Or an empty object, excuse me. So it's going to accept an object. It could be an empty object. And then within that object, we're going to have a parameter called context. And if the context is not present, then context is the document. And then we're going to change these document.querySelectors to context.querySelector. So in this way, when anything is calling gallery, if we pass gallery a context, it's going to use that context or that DOM fragment to perform its manipulation on. If we don't pass it that, then it's going to use the document, assuming it's running in a web page. And so we've made this change. Let's run the test again. Great, everything still worked, except we're still not actually testing any functionality. So what we're going to do now is, now that we've created the ability for it to accept a context or a DOM fragment, let's build that context. We'll say let fragment equal document.createElement, and we'll use a div. And then we're going to give that fragment some inner HTML that matches the expectation or the contract of this function. Now I'm going to use ES6 syntax for this template string so that I can wrap the HTML that I'm going to wrap. So we're creating a div that's a flyout, which is what our gallery function expects. Then we're going to create something to click on to close it. And now let's close the div. So now, instead of being forced to run this test in an environment that has a whole web page loaded, we're now passing this fragment as an abstracted part of the DOM into the gallery and testing it against that. And so let's pass that fragment now in. Say let my gallery, which is going to be our instance of the gallery, equal a gallery. And we're going to pass it this object where the context equals the fragment that we've passed. So we've now instantiated this gallery. And per the gallery function, it's now attached an event listener to the flyout close anchor within that context or within that fragment. So the next step, now that we've created it, we've abstracted the DOM, and we've created a gallery, we now need to observe the changes when an event happens. So we're going to write a function to observe any changes. So we're going to start by finding the button that we want to click on. We found the close button. Now we're going to attach an event listener to that close button. We're going to wait for a click event, and when that occurs, we're going to run a function. So within this function, now we're trying to observe whether the flyout exists or not, whether it's been deleted from the fragment or the context. So let's find the fragment, or the flyout in the fragment. Okay, we've found the fragment. Now we need to test whether it exists or not. And our assertion is that it should not exist. So I'm going to say assert dot is false. And we can cast the query selector to a Boolean, whether it exists or not, with a bang bang. Bang bang, you're a Boolean. One of my favorite sayings. So we're now observing the change that would happen when that element is clicked. The next thing we need to do is programmatically click that element. Close button dot dispatch event new event click. And I just want to point out that there are other ways to programmatically click on elements. The DOM has a built-in function called click. You can look it up on MDN. that's supported in a lot of places, but it's not supported within this unit test framework. And so we're dispatching an event more of in a more traditional way than using that DOM method. And using this method, we can use this for other stuff. We could dispatch other events like on touch start or other things like that, other than click. And so you go ahead and run this and observe what happens. Great, it worked. There's one more thing we need to add though to get a proper representation of the state. Because we've added this event listener now, we need to determine, because this is an asynchronous event, we need to pass in a property called done, and then we can let the assertion framework or the test framework know when it is done by calling it. There we go. So we've just refactored this DOM reliant DOM manipulating function into a function that we can now unit test. Now it's I think there is an objection to be made that you have to have this code in here, and the question might be, does that make your unit tests brittle? That if you change your implementation on the HTML in your template, now you've got to change the implementation of your unit test. I think to a point it does, but also that's desired to a point. You want your unit tests to break if your if your template changes and you forget to change your JavaScript, then you want that to break. So one way around that you could explore if you wanted to have this come in without having to have this in multiple places, more of a dry pattern, is playing around with the possibility of rendering that HTML and then importing it from a template. And so it's the same HTML both places. All right, let's go back to the presentation. These are my backup slides in case it went downhill in my live coding. All right, so just to recap what we accomplished with that, we took a dirty function, we abstracted the DOM, we simulated the input of the user, that click event, and then we watched for the click event. We observed the results and saw that that flyout actually was gone. We can now test this automatically, and the build can notify us if that fails. So that was one example of how to refactor your code, but there are other things that you might need to refactor. And so I have the final 3 or 4 slides are examples of problems and then solutions and how you could do that. So one problem is that you might have a private or hidden function. If you look on the left, we're exporting this init function, and it calls a function called inaccessible. Because we're only exporting init, inaccessible is inaccessible to the unit test. We can't pass it any data independently of init. And so one solution to that is to pull those functions apart and expose them as an API. So instead of exporting an init function, you're exporting an object which contains that API, including init, and now we've renamed this from inaccessible to accessible. Another problem is that you have direct DOM access, and that DOM may not be there. And so this is what we showed mainly in the example, was how to abstract the DOM away. So if you have a function that adds classes to an element, you can, and it relies on the document, you can pass in a document fragment and then do a query selector all based on that document fragment. Another problem is that functions are they're not discrete and they're not addressable, meaning they're anonymous functions. And the solution to that is to extract the anonymous functionality into units that can be tested into named functions. And this mainly occurs where you're doing things where you're passing a function as a callback. So in the example, if you have a custom sort function that you want to do on data, or a custom map function that you want to do on data to transform that data in some way, there's no way to unit test that specific map or that specific sort function. And so the solution to that would be to pull those out of the code, to pull that out of the function and name them. And then, so you have your sort function is now a named function, and you're applying that named function into data.sort. And so that way you can independently test those functions as units. All right, so just to sum it all up, we talked about rigor and professionalism. We talked about how rigor means, and professionalism is trying to do things that are right by the profession, trying to make good software, trying to do what's best for the users of our software, and that sometimes doing what's best for the users of our software and following best practices, we may have to put that above our needs or the needs of our short-term business needs. And rigor is being thorough, being exact, and making sure that what you've written really does what you think it does in all cases. And so we can accomplish some of that rigor by unit tests. The benefits would be easy deployments, people can learn real quickly, it creates the self-documenting API on top of your functions. We talked about the difference between pure functions and integration type functions and how we can, there's that middle area that's dirty, and then it's my belief that with refactoring and those principles of refactoring, that you can separate that middle area out. You can pull that apart and push most of it into pure functions and then push the rest into integration type behavior. We did a quick demo on writing unit tests for DOM manipulation and then talked about refactoring code to be unit testable and showed those different, some different problems and different solutions. Thank you.